Alright, hello boys and girls, this is Mr. Kizik, and welcome to part 2 of the proofs. And I just want to make a note here, I rushed through the last proof a little bit, and I did forget a step here. Right after we were given that's a parallelogram, well, by definition, what does it mean? It means opposite sides are parallel. So I would have to say that JK is parallel to LM, and JM is parallel to KL, and then I could say that the alternate interior angles are congruent. See, even I sometimes forget to a step or two with these proofs. And not the easiest thing to do. So on that note, let's look at number 5 here. So number 5 says figure CDEF is a parallelogram. So bam, gonna write it down. That is given. So because that's given to me, what I gotta define it. So that means then CD is parallel to FE. And CF is parallel to DE, because that's the definition of parallelogram. Well, what does that mean then? Then by, since they're parallel, that means angle DCF and angle CFE are supplementary because what kind of angles are they? They are consecutive interior angles. Let's look at number 6. So it says figure RSTU is a parallelogram. Let's prove that angle U is congruent to angle S. So because this is a parallelogram, what does that mean? That means then RS is parallel to UT, and RU is parallel to ST, because that's the definition of parallelogram. Now, what does that mean? Well, remember, that helps create these alternate interior angles. So we can mark these down here. So we can say that angle SRT is congruent to angle UTR. And we can also say that angle URT is congruent to angle STR, because they're alternate interior angles. Which was that, and then we can also talk about that RT is congruent to RT because of reflexive property. And then we can say that triangle URT is congruent to triangle STR because of ASA. And because we proved the triangles are congruent, we can prove the parts. So angle U is congruent to angle S because of good old CPC-TC. So that's what you'd have to do if you're given that something's a parallelogram. The only thing you can really say is that the opposite sides are parallel. Now, if I look at the next page here, it says all the properties of parallelograms are sufficient ways to prove a quadrilateral is a parallelogram. So these different things here, if I get any one of these here, if I show any one of these, then I can say, or I can mention these properties here and say that's parallelogram. So like here, the first things we've done and what we've done throughout the first couple was we can show that both pairs of opposite sides are parallel, which we did the alternate interior angles converse. We can show that both pairs of opposite sides are congruent. So again, in the first part of the video, let me find it here. Yeah, this part here, number 2, when you were given that the opposite sides were congruent, you probably were thinking, well, isn't that the definition? And you were right. But this is also another valid way. This basically proved that property here. So if I can show, or if they even gave you, hey, these opposite sides are congruent, you can just go right away and say, oh, opposite sides of a parallelogram are congruent. So any one of these properties would help you define or show the signs of parallelogram. So if I look at number 7, it says P is the midpoint of Ln and Km. So I'm going to write that down. I'm also going to refresh the page because it says loading. All right. So here, I'm going to rewrite the given. And remember, anytime we're given a word in the proof, there's going to be like we have to define a definition of. So what does that mean? P is the midpoint of Ln? Well, that means then that LP is congruent to Pn. So I can say LP congruent to Ln, or Pn, sorry. And then I can also say Kp is congruent to Pm. And unlike the other problems, like, the definition of midpoint. Now, what you could do too, and again, this can, you can do something like, oh, well, I got vertical angles, angle LPM is congruent to angle KPN because of vertical angles, and you can say those two triangles are congruent, and then you can talk about the opposite sides. But you got enough right here. What do I have here? I have in my diagram that the diagonals bisect each other. So I can go right saying that KLMN is a parallelogram because why? Diagonals of a parallelogram bisect each other. I have used one of the properties of a parallelogram to show that it is a parallelogram. If you think this is great, look at it here. It says triangle EDG is congruent to triangle GFE. Prove that the figure is a parallelogram. So let's write the given. So what does that mean? You have, I don't know where you want to begin here, because you have almost an infinite amount of possibilities to prove that this is a parallelogram. I think the easiest thing to say would be, oh, well, ED is congruent to GF because of CPCTC. And then I could say, oh, well, DG is congruent to FE because of CPCTC also. And now when I mark this, didn't I show that opposite sides are congruent here in this figure? I have, so I can go right saying that figure DEFG is a parallelogram because opposite sides of a parallelogram are congruent. Again, you've utilized one of the properties to help you determine that's a parallelogram. And there's many more proofs here because there's really many different ways I can go about doing these here. And yes, I get a little bit more complicated here and there. So let's just do one more together here. I know we'll be skipping a lot here, but I think one more will be sufficient. And in reality, too, there's so many different ways about doing these and so many different scenarios that we could do 2 weeks worth on this. So if I look at this one here, again, we start the given. It says angle XWZ, so XWZ, this whole angle here, is congruent to angle ZYX. And then it says that the triangle WXY is congruent to YZW. Well, how does that help me? Well, again, I got a couple different ways of going about doing this. But since those two triangles are congruent, I can say that angle X is congruent to angle Z because of CPCTC, right? And doesn't that look like one of the properties of a parallelogram? Sure does, because remember, one of the properties of a parallelogram says that opposite angles are congruent. So I can say that WXYZ is a parallelogram, because why? Because I have shown opposite angles of a parallelogram are congruent. Again, many different ways about going about doing this here. I could have said instead, oh well, angle. I'd have to talk about the two lines being parallel to each other. Maybe because I could have said something like angle X and angle XWY are supplementary. I could have done something like that. But make it easier for yourself. Look for common things there. Right? So, like I said, the only thing though, if you're given that's parallelogram, the only thing that you can say though is that the opposite sides are parallel. All right, and that's, like I said, there's other proofs, other different ways, and you can see some of them are a little bit more lengthy than usual. So what I want you guys to do is this. Two things here. If you are interested in extra credit, remember extra credit is supposed to be difficult. That's supposed to be something quite easy. And actually, let me reload the page because it needs to reload. For extra credit, I want you, if you want to do extra credit, whoops, let me erase that. I would like you to try number 14. Now, I will tell you right now, you won't need to use all the lines here. But it's a rather lengthy proof. So it told you that this big figure is a parallelogram. Told you something with N and J. So basically, I just want you to prove that JKNP, the top part, or JKPN, is a parallelogram too. It's lengthy, but again, it is extra credit. It would be worth 5 points. But your homework, I would like you to do 1 through, or try at least 1 through 5. 5 is a challenge problem, so I want to see what you guys can do with that. Remember, if you have any questions or concerns, please feel free to email me, and